3-in-1 application interface. So using one program, you can do macro, meso, and micro together. So you only need to launch one program. This is very unique. And it has very good user interface and documentation. Very good. What do I mean by very good user interface? So when you are doing modeling, sometimes you deleted a link wrongly. You want to recover that, so you want to undo. MSUM is one of the programs that can help you to undo. That's how I call it good user interface. In graphics, you delete a link. If you saved it, then you have to create it by yourself. And that happens in recent too. So this is good user interface. And you can ask for 30-day trial version from this link. And the demo license expires 30 days from installation. It has all the functionality, but you cannot save. I want to show it to you, but my laptop, it seems not connected, so it's not my fault. I will show it to you next time. The second one is coursing. Coursing, there's not a single model called coursing. Coursing is a bundle containing two packages. One is called NetSim, which is for modeling urban streets. The second one is called FreeSim, it's used for modeling freeways. So in coursing, if you want to create a network, you have to specify which part is using NetSim and which part is using FreeSim. That's very unique. Currently, it has only 2D visualization, and there's no demo version available. But it's very inexpensive. For example, you spend $5,000 for MSUM license. You only spend $500 for coursing. That's very different. And I cannot let you see it now. Ceramics is not a single program, it's a suite. It has many products. The most important one is called modeler. It's for create, simulate, and visualize. And we have many more here listed. I don't want to read it to you, but I listed them here. So when you go home, you can check them out. I wanted to show you ceramics, but I cannot do it, obviously. PDB Fusion Suite. It has only two software, two programs. One is called Resume. Resume is used as traffic assignment procedures, and it's very similar to Transcam. Resim is a microscopic traffic simulation. You can ask for a student version, which will never expire but has less functionality, or you can ask for a 30-day trial version from both from this link. I already uploaded my slides, so you don't need to write it down. And I wanted to show it to you, but what's the best way to do? Transmodeler is developed by Calibre. It's developed by Calibre, so it's compatible with Transcam. That's a big advantage because many four-step models are developed using Transcam. And it allows you, and this part is very unique, it allows you to apply 3 levels of simulation to the different parts of the same network and run them at the same time. So for the parts you are concerned about, run them in microscopic level. Otherwise, you can run them in higher level. This is unique. And they don't have any demo version. Synchro is the easiest one to use. And most of you have already learned it. It can be accessed in room 208, Header Hall. You can just apply for an account at this link. It's to be introduced in the Delft class, Traffic Operations and Design. Transims. Transims is the abbreviation of Transportation Analysis and Simulation System. It's supported by US DOT. It's open source. Characteristics of transims include that it has a lot of building blocks. So in transims, you don't follow a fixed procedure, but trying to play with the building blocks or utility programs. You combine the building blocks and you create your own application. That's how it's designed. Transims has no graphical user interface. And one thing very unique is that it's using the cellular automata, which is to be introduced very soon. Cellular automata is frequently appearing on the papers. But among all the simulators I'm introducing today, Transims is the only one that's using cellular automata. You can download Transim from here, and you will see it in future lectures. You will see all of them in future lectures.
Question. So what about the others? What do they use if they don't use cellular automata?
They are using cellular automata. Okay, that's a good question. Let's go to the next slide. I will describe to you. Cellular automata. Okay, this is the third important point of it. Remember this. Cellular automata is a discrete view of the space. In other models, the space, the rows are continuous. But by using cellular automata, you are dividing each lane into cells. Each cell is approximately the length of one passenger car. And if your car is longer, like if you have a bus, then you will occupy 2 cells. Cellular automata assumes that at every time step, one vehicle can only exist at either this cell or that cell. So there's no overlapping. Okay? And according to this assumption, the vehicle speed can only be like 1 cell per second, or 2 cells per second, 3 cells per second. That would give you a very discrete distribution of vehicle speed. So they are not continuous anymore. The advantage of using cellular automata is that it reduces the computation time. And it's using simpler car following logic. It's using car following logic, but it's simpler. I will introduce that in the following lectures. Any question about this one?
So the other models use car following logic, different type of car following logic.
Yes, it's simplified car following logic.
But perhaps Transition would use more advanced.
Yes, because they treat rows as continuous space. Cellular automata is equal to discrete space. Don't you want to ask any question about this segment? Okay, I'll give you a question. If you are using cellular automata, what do you do with this part, within the intersection? There's no way to do that. So Transims doesn't have any simulation of vehicle movement inside the intersection. It assumes that you enter this node, enter intersection at a certain time. And after several time steps, it appeared here. It doesn't simulate any movement inside the intersection. Okay?
We have to put a space between 2 cars. Or it
Space?
can, yeah, because we are the one entry cell between 2 cars. So that should be always the case, or it can be car to in.
That's part of the car following model. I guess sometimes when it's congested, they will be squeezed, and there is no space between vehicles. That depends on the car following model. How do you implement that? That's a good question. I have no idea that if Transims require one space.
I think it depends on the size of the cell you're using. So if you're using the size of, you could use a size of 7.5 meters, for example. So in this case, you might not need to have an empty cell.
Right, that's what I'm thinking.
But if you use the smaller cells,
Yes, I can recall that in a paper I read, the vehicles are only traveling in a certain way that they don't overlap each other. So as long as they don't there's no collision, you will be fine. The last one is sumo. Sumo is famous because it's a style of Japanese wrestling, right? But here it doesn't mean that. It means simulation of urban mobility. It's supported by German Aerospace Center, and the abbreviation is DRR. So you must be very confused why this GAC is called DRR. That's because this thing, okay, this stage. And it has some user interface, but very crude. And it's open source. It's expandable. Oh, not expandable, it's expandable. Sorry. This place should be expandable. And it's very popular for the evaluation of this vehicle-to-vehicle application and vehicle-to-infrastructure communication application. There has been a lot of plugins developed using Sumo. So if you are doing this research, check Sumo. And you can download them from here. Luckily, I prepared a snapshot of Sumo, so at least you see something today. So this is the crude graphical interface of Sumo. You can have several different views of the network. But as you can see, the toolbars, the menus, are very limited. So you cannot depend on it to develop a very complex network. So now it's the end of lecture. I'm really sorry that I couldn't show you those applications today, but I probably can show them to you next time. And in the next lecture, I will perform a magic trick in front of you. So please don't be late. Thank you.
Hooray. Clap after me.